Hey everyone, we're here to talk about question 14 on the Chapter 5 practice test for statistics. So let's read through this. We've got heart disease is the #1 killer today. Suppose that 8% of patients in a small town are known to have heart disease. And suppose that a test is available that is positive in 96% of patients with heart disease, but is also positive in 7% of patients who do not have heart disease. Okay, so I'm reading through this and immediately I'm thinking we need a tree diagram for this. Okay, so let's start with our tree diagram, and with our tree diagram we always need to start thinking about what is the first event that's going to happen. Do I have any events that are single events and are not and events or are not the events conditional probabilities? And of course I do. I know that 8% of the small town patients in a small town are known to have heart disease. That's not linked to anything else. That's just heart disease. So heart disease, 8%. Make sure you put 8% and not 80%. That means that the rest of the people here do not have heart disease, and that is 92% do not have heart disease. Now that we've got that out of the way, we can do the next thing, which would be the heart disease test. Now, for those who have heart disease, we know the test is going to be positive for 96% of them. So we'll put a 96% of the people who have heart disease will get a positive test, meaning the rest of them, the 4%, will get a negative test. Down over here on the people who don't have heart disease, they'll get a positive test 7% of the time. Make sure you put 7% and not 70%, which means that the ones who do not have heart disease, they'll get a negative test 93% of the time. So really, that tree diagram is not very difficult. We should be able to have everybody doing a nice tree diagram. Now the next part here is these outcomes all lead to AND probabilities. So let's figure out these AND probabilities. This is the probability of heart disease and a positive test result. And that's equal to 0.08 multiplied by 0.96. So let's go ahead and, highlight that. That's that 8% and then that 96%. And when we multiply that together, we get 0.0768. Now the next path we're going to take is going to be to the negative. So this is going to be heart disease and then negative. So let's write down what that is. This is the probability of heart disease and a negative result. And if you take a look at the things that we passed a 0.08 and a 0.04. 0.08 times 0.04. And that is 0.0032. Okay, next path we're going to take is this one right here, which leads me to no heart disease. So heart disease complement and a positive result. That's a false positive because we're getting a positive result for someone who does not have heart disease. So let's multiply that out. That's 0.92. And then moving on to 0.07. And we'll write that out. 0.92 multiplied by 0.07. That's equal to 0.0644. Now the last path we do, that's 92% no heart disease, and then 93% to a negative, and that leads us to the next probability, and that's the probability of no heart disease and a negative test result. That's 0.92 multiplied by 0.93, which is 0.8556. Now, the magic of this diagram is that we have created all of the disjoint outcomes that are possible from this experiment, and we've also figured out the probabilities for all of those disjoint outcomes. Let's do a little bit better of a job highlighting everything here. So now we can answer all the questions that you could possibly ask about heart disease and this test because we know all the outcomes. So the first one, if a person is selected at random, what's the probability that they have heart disease and test positive? So that is saying, what's the probability of heart disease and positive? And we just need to look for that in our chart. Our chart tells us that it is 0.768. Okay. Now the next one. If a person at random, what's the probability that a person at random does not have heart disease but tests positive? Now, read that really carefully because it doesn't say that one of these is always going to be true. We're not saying they have heart disease given that they have a positive test. We're just saying that they have a heart disease and they test positive. So what's the probability that a person does not have heart disease? Sorry, I think I read that a little bit backwards. Oops. There we go. That they do not have heart disease and they test positive. Just like before, we can read that number off of the chart. We just got to look for heart disease complement and positive. There it is, 0.644. Okay. If a person is selected at random, what's the probability that they have heart disease? What's the probability that they test positive? So the probability that they get a positive test. Now that's a single event. If we were looking at a two-way table, we would just be looking at a marginal total. But we're not looking at a two-way table. We're looking at a tree diagram. So we need to find all the outcomes that have a positive result. Okay, so that's the probability of heart disease and positive, and probability of no heart disease and positive. Those are the only two of our disjoint outcomes that have a positive result. And luckily for us, we color-coded them as yellow. Now we just have to add their probabilities. That gives me a 0.1412 probability that a randomly selected person is going to test positive. And the last one here is, if a person tests positive, what's the probability that they have heart disease? Okay, so now this is conditional now, because now we're starting with the statement, if they test positive. So we know they test positive. Ordinarily, I would go ahead and highlight the line in the two-way table that had that was for the positive, but we don't have that two-way table, so we need to do this using the formula. So what is the formula for this conditional probability? It is the probability of heart disease and positive test result divided by the probability of a positive test result. Luckily for us, we have all of those numbers. So what's the probability of a heart disease and a positive test result? That's 0.768. What's the probability that someone tests positive? 0.1412. And let's divide that out real quick. 0.5439. So this is kind of a scary test if you think about it. Because we just found out that if someone tests positive, there's only a 54% chance that they actually have heart disease. So in my book, I would say that the test that we're talking about in question 14 is a bad heart disease test. So that kind of does it here for our question 14. We're going to do another question next, question 15, if you're following along sequentially. See you there.